Hello, everyone, and welcome to Research Ride. It's a 30-minute journey from idea to implementation of research programs in the Department of Medicine. I'm your ride leader, Charlie Searles. I'm a faculty member in the Division of Cardiology, and I'm the Associate Vice Chair for Research in the Department of Medicine. Today, we will be touring with Dr. Jessica Alvarez, who is Associate Professor of Medicine in the Division of Endocrinology, Metabolism, and Lipids. Thank you so much, Jessica, for joining us today.
Thank you, Charlie.
And I was hoping that you would give us just a little bit of background about yourself leading up to the time that you joined Emory and past that.
Sure. So my background is actually, I started off as a registered dietitian or training to become a registered dietitian and fell in love with research as part of my master's thesis work, and just sort of stayed at, I was at the University of Alabama at Birmingham, loved doing my master's thesis work, stayed and did my PhD work in nutrition, and then came to Emory as a postdoc in 2014, I think, 2011, and have been here since. I never left.
Wow. So that's interesting. So you started graduate school that you would be more clinically oriented, and you became more of an investigator?
Yeah. Before, when starting graduate school, when I went to do my dietetic internship, I was just going to be, I wanted to actually work with eating disorders, which is far off from what I'm doing now. But I wanted to be a clinical dietitian. I wanted to help people. I wanted to help them, guide them in what kind of foods they should eat for better health. But along the way, I realized research was where it was at, and I felt like I could make more of an impact doing research behind the scenes compared to working one-on-one with someone trying to change their diet.
And I understand that you're also involved in the CTSA program and the Cystic Fibrosis Research Core Center. Can you tell us a little bit about that role?
Yeah. So for my hat, or my role in the Georgia CTSA is as director of the certificate program in translational research. And this is a program for graduate students, junior faculty, to basically, it's a 16 credit hour course, and trainees get broad exposure to experiences across the research spectrum. From most of our students start off with basic science, some of them are epi, but they get exposure to epidemiology, health services, clinical research. And so my role in the certificate program is just to help facilitate students through there. And within the Cystic Fibrosis Center, probably 75% of my research is in cystic fibrosis, looking at nutrition and body composition. And so I am associate director for one of the NIH-funded CF, or cystic fibrosis cores, that deal with lifestyle and behavior and nutrition as just a core center.
That's awesome. Just quickly, what do you like to do in your free time?
I wake up at 5:30 in the morning and go do CrossFit so it's not really my free time, it's before everyone else wakes up usually. But in the last 3 years, I've gotten really into weightlifting and just doing really high intensity exercises.
So is this Orange Therapy? Orange Therapy?
No, Orange Theory. No, I've never done Orange Theory. But Orange Theory is also very high intensity. CrossFit is more, it combines more heavy weights. So I get to do things like deadlifts and overhead squats, and it's a lot of fun.
And what about like pushing big tires around?
Yeah, I see a lot of pictures of that. My gym doesn't do that. I'd like to. I think it would be a lot of fun. I feel really hardcore when I'm doing that.
Well, I admire the early morning workout. It's shows a real commitment, I would think.
It won't get done otherwise.
So you talked a little bit about your research. Can you just give us a bit more overview of what your research program is or does?
Yeah, absolutely. As I said, so most of my research is in people, clinical populations with cystic fibrosis. I study the role of nutrition and body composition on health outcomes in this population and other populations as well. So I would consider most of my research to be clinically oriented. When I say body composition, I mean muscle, fat, visceral adiposity, and just looking at the roles that they have on outcomes such as insulin resistance or risk for diabetes, or even cardiovascular health outcomes. And then same with diet, what nutrients or what dietary patterns might influence some of the outcomes in our patient populations. And then another big portion of my research deals, and this one has been new to me since Emory, or something I've been working on since I came to Emory, is to look at plasma metabolomics and sort of what is the association between what we eat in the diet, nutrition and body composition, and what metabolites show up in our blood. So we call it nutritional metabolomics.
Wow. I'm just curious about the cystic fibrosis focus of some of your work. How did you get into that?
Yeah, so this is a very special population. The cystic fibrosis it's a genetic disease that is very heavily influenced by nutrition. The defect in the gene mutation, leads to severe malabsorption because of a very viscous, thick mucus secretions that build up within the body. And so we see a lot of lung disease in cystic fibrosis, and that's the primary defect of in CF, but also pancreatic disorders where because of the buildup, the enzymes that are released by the pancreas, which are needed to metabolize our nutrients, are not absorbed. So we see a lot of malabsorption. And for a long time, patients with CF would, because of lung failure, on top of malabsorption or with malabsorption, they had a very early, very short lifespan, I would say. So say in the 80s, the lifespan was maybe 20, 30 years old, versus now there are these amazing new treatments where patients with CF are living well past their 40s. And so we're at the point where we're relooking at diet to see what kind of health outcomes their diets can have, just to improve survival, to improve their quality of life. So one of the main issues with CF was, because of the malabsorption, is that they were eating very high fat, high calorie diets for a long time just to be able to get past this malabsorption. And so now we are not so sure. It's sort of in the whole community is in this state of transition where they may not need so many calories or so much fat in their diets, because we're not seeing as much as many nutrient deficiencies and as much malnutrition as before. So my research program is sort of headed more into what kind of foods can we eat, can we feed our participants, our patients with cystic fibrosis in this changing landscape to improve their overall survival.
And so body composition is not so much of a variable in this population. Is that wrong?
No, it is. So another part of one thing with CF, with cystic fibrosis, is that one of the major clinical outcomes, I guess, or monitoring outcomes that we've looked at for so long is body mass index, which is basically just height over meters squared. But some of my research and others are showing that even when you look at two people who have the same BMIs or the same body mass index, their proportion of fat versus muscle can be very, very different. And so it's that proportion of fat versus muscle that is making the difference as far as clinical outcomes compared to just your height and your weight squared. So one of the things that my program is trying to do is sort of move away from just using body mass index as a clinical outcome and more looking at more robust measures of body fat, percent body fat, lean mass, muscle, bone.
How do you do that?
There's several tools available. Probably one of the clinical gold standard, I'll say, is using Dexa Scans. And it's a tool used pretty commonly for endocrinologists to assess osteoporosis, osteopenia, but we can also get at muscle and fat. I also use MRI scans, magnetic resonance imaging, and we can get really into detail within of how much fat is in, say, the visceral area, so that surrounds the organs, or even in between muscles. So there's another level of detail that we can get as far as body composition goes. And then there are other tools that might be a little bit more clinically useful that we're testing in the CF population, such as bioelectric impedance analysis, which is sort of a bedside tool. And even ultrasound is one that we're going to try to get into soon.
So I'm just thinking from, sort of the clinic standpoint, we use BMI, frequently, but what you're arguing here is that might not be the best predictor of risk.
Correct. I think BMI is fantastic to catch people at the extremes. So those who are really malnourished, or those who are overweight, obese. But when you start looking at people towards the middle, one of the terms that I use that I wish I could find a new term for it, is normal weight obesity. And so basically you're walking around with what would be considered a normal BMI, but your adiposity levels, your fat levels are a lot higher than what they should be. Or your muscle, your lean mass is less than what it should be. And so that has been shown to be correlated with higher risk for diabetes and cardiovascular disease. So it's just one of those things that, you look at somebody and you see their BMI and it looks fine, but it really might not be until you wouldn't know that until you do more testing.
So the cystic fibrosis interest or focus of your research program is really sort of in line with your nutritional training or nutrition background.
Definitely. I actually, fun fact was, after I finished my master's program, I was going to be I actually interviewed to become a cystic fibrosis dietitian at a children's hospital. And a week later was when I decided to stay and get my PhD. But it was when I got to Emory. So I kind of thought my CF, cystic fibrosis career was over. But I got to Emory to be a postdoc under Ventang Precha, and I wanted to learn more about vitamin D and learn about clinical trials under him. And he just so happened to have just received an NOA, a notice of award for a vitamin D supplementation trial in adults with cystic fibrosis. So I was just elated to be able to come back and work with that population. And it was there that I realized that nutrition was still so important for this population, and kind of where I started my general nutrition and CF research career.
You're collaborating obviously with people in different parts of the Department of Medicine.
Absolutely. And yeah, so I collaborate with pulmonologists. I collaborate with basic scientists, all doing CF research. It's an absolutely wonderful community. And then just kind of going back to it being a lung disease, and your mention of it being a multi-system disease, I think that's really important to remember. It is for a long time, people kind of focused on the lung, but with new therapies, the lung issues are not completely gone, but we are sort of able to start focusing on sort of extra things such as diet and nutrition, body composition. So it's a really exciting time to be doing research in CF right now for nutrition, for anything really.
And this has also led to sort of other parts of your research program, including the vitamin D work.
Yeah, the vitamin D work was, that's kind of where I started doing research in CF. But going back several years, my PhD work was looking at just sort of the relationships between vitamin D status and risk for diabetes or insulin resistance. I was really obsessed with vitamin D for a long time. I just loved it, which is why I came to Emory to work with our vitamin D guru, Benteng Fricha. Vitamin D is it's a piece of the puzzle. We don't want to walk around with vitamin D deficiency. If you have full vitamin D status, you're doing great. It's when we get into the deficient mode that we start seeing some of these relationships with everything. But it's hard to tell. So your vitamin D levels, or 25 hydroxy vitamin D levels, are highly influenced by anything: the sun, how much activity you get, what you get in your diet. So one of the sort of hard things about studying vitamin D is that your vitamin D status could just be an overall marker of good health, of just being in general good health. You're an active person, you go outside, you eat generally well, then your vitamin D levels are usually pretty good. So it's confounded by a lot of things.
So I understand that you should be congratulated for a recent notice of award yourself.
Yes, thank you. Well, so I haven't.
Can you tell us what that notice of award was for?
Yeah, well, so I have not gotten the notice of award, so I haven't celebrated yet, but it was
Close to the notice of award.
Oh gosh, I hope so. It was an application for an R01. This was the third submission actually for this grant. And what I'm hoping to do is a dietary intervention looking at, it's a feeding study, looking at low added sugar compared to a typical cystic fibrosis diet in adults with CF. And what we want to see is if we can improve with just a simple low added sugar intervention, if we can improve glucose tolerance, so their risk for diabetes, because adults with CF are at very high risk for diabetes. And it's also to see if we can improve their body composition, so see if we can decrease their visceral fat, as well as doing a more mechanistic aim and looking at whether low added sugar can improve their redox, so decrease their oxidative stress, basically. So we'll see. I got a really good score, but I'm still kind of being tentative, and I haven't popped open the champagne about it yet.
I understand the interval between a good score and actually getting the notice of award is can be good and bad, I suppose, right? I guess it's a bit of waiting, but you feel like you should start getting your project going.
Oh, absolutely. And that's something that that I have been doing is thinking about, okay, I need to get my IRB approval. I need to start working out protocols. I need to figure out equipment issues. Where am I going to fit all this equipment that I asked for? But I feel like I'm in a very good place. I'm in a happy mood about it. Those 3 submissions were killer.
So I'm just curious about a diet intervention. What is that? What does that look like logistically? How do you have these participants and you're giving one group one diet and the other group another diet? How do you maintain that, or make sure that is sort of they follow
Yeah.
the
So,
instructions, or they take the right diet, or
right. Well, so this one is going to be, if all goes as planned, it will be a feeding study. So we'll use our, we're going to work with our Georgia CTSA bionutrition unit, and they are going to create the meals, package them up, and we'll randomize folks to receive pretty similar meals. The calorie content are going to be the same between the two groups. The carbohydrates, protein, the macronutrient levels will be the same. Only difference is that one will be a higher added sugar and one will be a very low added sugar diet. So we have to trust our participants to eat only the foods that we provide. And we will have some element of just trying to.
so the patient will get, or the participant, I'm sorry, would get a grocery bag, or I mean, they come by and pick up a suitcase full of food. How does that work?
What we are hoping to do is be able to deliver to the homes. There's so many meal services available now. Just you can get foods or packaged meals shipped to your house. So it'll probably be every 4 days we'll ship breakfast, lunch, and dinner and snacks. And hope and pray that participants only eat what we give them.
And you don't, I mean, you expect them to maintain, body weight neutrality during the course of this, obviously.
Yeah, that's going to be one of our one of our goals, is to make sure that they don't gain or lose any weight, any body weight. So we're giving them scales to measure themselves at home. And we'll call them pretty frequently. And if it looks like they're losing or gaining weight, then we adjust their calorie levels that we give them. So it's going to require a lot of frequent contact with them to make sure everything's going okay.
You need a big team to get this study done.
Absolutely. And that was actually one of the critiques that, not a critique, but my program officer came back, and he's the one who has been helping me over the last few years, and said, there's been concerns about the size of your team. And so this weekend I have to write back a response of why I need every single person on my team.
They thought the team was too big.
Yeah, they said there's a lot of people on this team, but I think there is a role for everyone, and I need every single person on deck for this. So I just have to come up with a very good response to my program office.
And the idea for this proposal came from your previous work with cystic fibrosis patients.
Correct. Yeah, this was it was based off of observational data, where we looked at we had adults with CF versus healthy controls, and we ran Dexa scans on everyone. And even though our cohort or CF cohort was pretty well matched for BMI and age with our healthy controls, our adults with CF had almost twice as much visceral fat compared to our healthy controls. And when we looked at their food records, added sugar intake was positively correlated with how much visceral fat they had. So the more added sugar intake, the more visceral fat we found. And this was just observational data. But I pushed and was persistent and kept writing this grant, and finally they took it, hopefully.
So no metabolomics in this study.
So this one actually does have metabolomics. So I mentioned a basic, more of a mechanistic type aim, looking at changes in redox, and this would be changes in plasma redox. But because I do love metabolomics as a tool for research, I sort of snuck in a sub aim to look at changes in the plasma metabolome before and after the dietary intervention.
And when you say redox, what do you can you just explain that a little bit more?
Yeah, so it's essentially just a measure, well, an oversimplification of it would be to say sort of measures of oxidative stress, but what we're looking at is changes in systemic glutathione and cysteine thiol-related redox. And these are, so glutathione is the primary intracellular antioxidant. And so we work with a collaborator in pulmonary, actually, Dean Jones, who sort of established this method to look at redox using glutathione and plasma cysteine levels.
So the hypothesis here is that the low sugar diet would have lower redox?
Correct. So lower sugar diet would reduce oxidative stress. And we'll measure that looking at changes in the plasma in glutathione and related metabolites.
You've been able to utilize metabolomics in all of these different projects.
Yes, yes. I think one of the things is trying not to become overwhelmed by the thousands of metabolites and sort of trying to keep focus and where is the story that you're looking at. And so you start finding patterns, and I feel like over the years you kind of get better at looking at the patterns with metabolomics. But I've been able to apply it to cystic fibrosis. I have a grant with Cecile Lahiri looking at metabolomics in people with HIV. So I've been able to use this tool to be able to collaborate with several investigators across Emory, and it's really fun.
Do you have a favorite metabolite?
Ooh, that's a great question. Right now, my favorite metabolite is linoleic acid, but that's just because it's sort of my research topic du jour. It is an omega-6 fatty acid. You can only get it through your diet. And it's one that we've recently found to correlate with negative outcomes. So we found recently, we published that higher plasma linoleic acid was associated with lower bone mineral density and higher fat, higher adiposity. So that one right now is my favorite metabolite. And when I see pathways, I immediately search for linoleic acid and related pathways.
So it's interesting that your work goes from assessing what people are eating to looking at the chemicals that are in their blood.
Correct. And what
I mean, that's quite a range there, right?
Well, what I hope to do one day, and this is really long term, is when the typical tools that we use to assess what people eat is you tell me what you ate in the last 24 hours, and I'm going to believe you, because that's all I have to measure. So if we can look at someone's blood and know for a fact that they just consumed an apple or something, I feel like that would be really powerful.
That's something that we might have in the clinic, you're saying, like
one day. I hope to be able to do that with diet one day.
We would prick their finger, and we would get a drop of blood, and you would tell, and we would measure linoleic acid in a drop of blood and figure out not necessarily what they ate with linoleic acid, I guess, but
absolutely. Or even just be able to figure out, like, oh, you look like you've been eating too much red meat, based on your blood. Let's ramp up the fruits and veggies. Just even dietary patterns, I think, would be a great use for metabolomics without having to rely on these pretty inaccurate self-reports of what
surveys, I guess, right?
Right.
You made this transition, right, from sort of postdoc to sort of career development award, right, to RO1. What advice would you give somebody who, you've done the path now. So what is the advice that you would give to somebody who's looking at this path now?
I think part of it is, and I feel like I've probably learned the hard way, is just to stick with it. And you have a path, and try not to diversify yourself too much. But at the same time, keep a few other avenues open, because you just never know what might come up. For example, me working with HIV, I never thought I would work with HIV, but I am able to now. I also think finding not just one mentor, but maybe a community of mentors that will really serve as your champions. And I think that's one of the reasons I have been able to get to where I am is to have several champions to speak up for me, especially as a postdoc and really early instructor and early junior faculty, when I was too scared to speak for myself.
So multiple people, you think?
Definitely multiple people, and there are so many different kinds of mentors. So you can have your science mentor, but maybe even a life mentor, someone who shares similar interests with you, who's been there before. It all, to me, it starts building this like little community of folks who have your back.
And it doesn't require that these people actually talk to one another.
No, they don't have to. Sometimes I like to keep my mentors separate. I like what this one's saying, not what that one's saying. Sometimes.
Do you do this? Is it official for you? Is it official? Like you ask somebody, will you mentor me?
For me, I think some of them have been more organic, and people have just become mentors through interactions. But there have been, so for example, for my my career development award, it was a more formal, will you, reaching out to someone, especially someone I didn't know, but had the expertise that I needed. What would you consider being my mentor? So probably a combination of both, I would say.
What would you say is a best piece of advice that you had received as a person coming up this pathway? It sounds like the multiple mentor was something you came to yourself, I guess, right? But was there any other advice that you were given, or?
Yeah, I think one of them has been to sort of find, as you're, in your training and everything, find a tool or a niche or something that people will want to come to you. So for example, mine was being able to do nutritional metabolomics, at least being able to interpret it. And I've had so many other folks say, hey, do you want to collaborate? I'm interested in metabolomics. Can you be a co-I? So finding some tool or some niche that can be applied to other disease states or other areas, that people will seek you out for this. You become an expert in this one thing. I would say that is probably the best advice that I've received, or at least starting out. Received lots of great advice, but that was one that really stuck with me, and that I have been trying to work on.
And it's worked well for you, it seems.
So far, knock on wood.
Well, I've really enjoyed hearing about your research, and I'm sure our listeners are motivated by your words of advice. I wanted to ask you though, if you were stuck on a desert island and you had to have one food and one drink, what would those be?
Oof. Okay. The drink would be really boring. I have to stick to water, clean water, purified water. But the food, can it be a combination of foods? Like
one food.
Like a hamburger, a cheeseburger. Does that count as one?
Oh, sure. Yeah, that's fine.
Okay, it would for sure be a cheeseburger. It's got the perfect amount of meat plus dairy. It would have tomatoes and lettuce to it also. So
you're thinking from the viewpoint of a nutritionist, what would be the optimal survival food?
Yep, I would go with the cheeseburger.
So no ice cream or sweets or otherwise.
No, I'll find some fruit on the island somewhere.
All right. Well, I'm very happy to know that. Well, I would like to thank you again. Thanks so much for joining us today. This was an awesome tour of your research program, and I wish you the best of luck.
Thank you very much.
And we look forward to being with you again. This podcast was brought to you by the Emory University Department of Medicine, Office of Faculty Development and Research, and the Strategic Advisory for Research team, the START team.